Thank you very much, Anna. And I will try to be brief as well to save some time. So, yes, I think I should also start with, our main thing that we're working, the biggest thing is bio-CCS, but we're also are operating a biochar, have been operating a biochar pilot that is actually being rebuilt right now, but that is co-producing biochar and district heating. So we're also into that market as well. But that has already been taught quite extensively about. So I think I will skip further on to the bio-CCS. I think so in the chat, and there's also a lot of discussion in general around biomass. And I think one of the key concerns of bio-CCS is sustainable forestry in the end, and sustainable sourcing of biomass if it's not sourcing of biomass from forestry. And I think really we need to recognize that biomass is not biomass. There are so many different ways of harvesting biomass, which some of them are really bad for the climate, while some, like many residues that you can find from different sources, might have many benefits on the other hand. But there are big differences, and that's also why we don't see, for our sake, a competition between bio-CCS and between biochar, because biochar is actually better at some sources of biomass that have a high alkali content that you can not use in a combined heat and power plant, because then you would have corrosion. So there might not even, for that reason, always be. We see them as complementary, that they are very complementary sources of negative emissions. I think we can skip a lot of these pictures, actually, so to save time. This one, of course, in Sweden, and there was some comments in the chat. It was also a link to a report that sort of summarized some of this. Sweden and the Swedish government has made a big inquiry on how to reach the net zero target Sweden has set out for 2045, which is basically under its national determined contribution. And so they looked into how much are the remaining emissions and how much of these are we going to basically need to reduce by doing complementary measures. And in Sweden, we have a really big bioenergy sector. So there is a potential for 30 megatons of up to 30 megatons of bio-CCS in existing point sources. So not adding any more biomass, just looking at the big point sources we have already in the pulp and paper industry, but also some in district heating and combined heat and power. But they looked into how much negative emissions to bioenergy CCS is required by 2045. And what they realized, so Sweden has some 50 megatons today. And if all point sources of fossil CO2 is reduced by 95%, all CO2 from traffic is removed, then we still have some 20% left, so some around 10 megatons in the end. And depending on how efficient technology development and within other carbon removal technologies are, and how we see technological development also in reduction measures for fossil emissions, there will be a demand for 3 to 10 megatons of negative emissions through bioenergy carbon capture by 2045. And here I think it's a really good that if you go into counter emissions, you really need to discuss this reducing versus removing, because reducing, basically what you do is you take your, in this paint picture that I love, that is in Swedish, olja means oil, but I think you can sort of get the notion of that. It is in the end about putting back your own CO2 that comes from the geosphere back into the ground, while the right use of biomass can actually gather CO2 from the atmosphere and store it permanently underground. And of course, this is photosynthesis. I think there have been some discussions on the benefit of different carbon removal technologies in direct air capture. I think the downside is that you have a very low concentration of CO2 in the air, while of course it takes a while for biomass to do and photosynthesis to do its work. So, but in the end, for our case, we have in direct air capture, you have some 400 ppm of CO2 in the atmosphere. That's 0.04%. And in a good combined heat and power plant, we have up to 18% of CO2. That of course makes it easier to catch, but the downside then is of course that photosynthesis is slower from a year up to several decades. So that's also sums back to this biomass not being biomass. It's a wide spread of biomass with carbon cycles from within a year to multiple decades. That's the difference also in biomass. I think a lot of these were supposed to be hidden, so I will run forward. This is the site that we're looking to develop, and our board has taken a decision that we should have large-scale BECCS at a first unit by 2025. The reason why we're also working on this date, specifically 2025, is that this governmental inquiry that sort of gave the conclusion that we require 3 to 10 megatons by 2045, they also realized that then you can't make it happen overnight. You need three to 5 projects by 2030 for this to be a viable options. So they proposed that Sweden should do a negative auctioning for CO2 removal through bio-CCS as soon as possible, to have projects in the range of 1.8 megatons by 2030. So that's the proposal. And the reason why they're looking specifically at the negative auctioning is that a rightly formed negative auctioning would create incentives for the market actors to work in creating a market for voluntary actions. So if you find financing in a voluntary market, you would be more have a higher degree of competition and be more competitive in the auctioning process, so that you would bid in on a lower price. And that will then reduce the cost of the government in the end to get these projects started, while incentivize the market for negative emissions to start and develop. And by that, as I know we're sort of running out of time, I would just conclude that I think one really big benefit of doing this on combined heat and power is that from our perspective, carbon capture is in the end an exothermic process, so it provides heat. We take CO2 at 40 degrees and we remove it at somewhere around -20. So that's 60 degrees reduction in temperature that you can use as heat. So theoretically, you could get energy out of CO2 capture. What we see for our product is that it's reasonable to end up maybe so for capture and liquefaction, we could keep the total energy penalty below 2%. That's perfectly feasible for combined heat and power, which I think is a great benefit as well. So by 2025, we hope to be up and running. That's the goal. Our CEO is standing behind us with a blowtorch, keep looking into that we keep our pace. And I think I will stop there.